Okay, so today's topic is NAT. So I've basically got a 3-router topology. So R1 here will be the border router in this topology. And so we've got 192.168.10.20, 30, and 40. There's no LAN hanging off of R1. And so this will be the border router, of course. So there'll be an outside interface and 2 inside interfaces. And so this will be a good target to test our connections with. And also I've got a server on each side as well, just so that we can do some static NAT. And I'm also going to do a port forwarding NAT as well. So so just a bit of a demo for that as well. So, okay. So, of course, NAT is how you can share one public IP address at a time. And so the one I'm going to implement is actually going to be just sharing the IP address here. So I think it's 10.0.0.2, so it's on serial S010. And so, of course, S010 is the interface that needs to be the outside. So that's the first part of our config. And then the 2 other serial interfaces, which of course are S000 and 001, of course are the 192.168.2 and 3 networks. So they're the IP NAT inside interfaces. Now, so of course that's the orientation of the router. And so, of course, it's hanging off the page, isn't it? And so, of course, then we need to define the list of valid internal addresses. Now I've used an access control list here. And so, of course, basically I've just done 192.168.0.0. And with the wildcard mask, what I've done is I've just set the last 3 bits of the 3rd octet to be ignored, as well as all of the 4th octet. So basically that just takes in subnets 1, 2, 3, and 4. Also does network 0, which I'm not using, but anyway. And so of course I needed the last 3 bits of the 3rd octet, because 4 is 100. And so that is going to be the variation is between those, the last 3 bits in the 3rd octet. And so that's how I've done that in 1 line. Of course, I could have done 3 lines of, 192.168.10 and 20 and 30 and 40. Sorry, 4 lines. And that would have done the job as well, but I don't know. I thought I'd try and incorporate it into 1 line. So that's all good so far. Now, what have I done? Oh, I must have cut instead of, I actually modded this file, so this is slightly different to what's up there at the moment. Now, Now, yeah, I must have cut instead of copied when I made this extra stuff here. So S010 is, now this is the NAT commands. And so I'm going to do an IP inside. So I'm just doing a static NAT for IP address 192.168.120. So that's the server there that will have a NAT translation. Okay. Yeah. And so it's going to use 10.0.0.3. Now, basically, here we have the 10.0.0 network anyway. come on. And so, of course, 2 is used on R1. 1 is being used on the ISP router, have I called it? Yeah, ISP. And so basically beyond 1 and 2, which are already in use, I've used address 3. And so because it's in the same subnet as that should work nicely. This router will know how to find that address as a destination. So that's the static NAT. And so we'll apply that and test it a little later and see that it works. And so then there is the next line is that port forwarding NAT. So as opposed to this server is basically exposed to the internet. All of its ports are exposed. So someone somehow goes to 10.0.0.3, any service on that server is actually visible from the internet. So I've basically opened it all up. So that's handy. If you're running a lot of services off that server, you only need the one translation. Of course, the downside, of course, is, as I said, you've exposed it to the internet. So here is another way you can do it with that port forwarding example that was in the curriculum. And so, of course, it's this address here. So it's 192.168.420, and so that's this server here. And so we're just doing a port forwarding for port 80. So basically, now I'm using 10.0.0.2 here because that's the outside-facing interface on this router. That's the shared one. And so if someone attaches to that IP address using port 80, the router will then forward it to the internal or the inside local as opposed to the inside global. I suppose I haven't used that terminology yet today. And so we'll translate it into this inside local address and still with port 80. Now, you can actually change port numbers when you do this, but for a web browser, I typically wouldn't. And I'd certainly have, if I wanted to be easily accessible from the outside world, you'd do the port 80. Now, of course, that's great. That's outside hosts can now connect in to those two servers. This one, web server only. This one, you can actually hook in using any port number. So, of course, now we've got to make sure that internal clients, so I've only got a few here, can actually connect outbound. And so this is when we're finally going to use this access list that I spoke about earlier. And so it's IPNAT inside source. And so the source is list 1 as opposed to a static address. And so, of course, these are the defined range here. So any host number basically from 0 through to 7, I think, would be able to get out there in the third octet. And then instead of using a pool, we actually use the interface address from that interface. And so, again, that's going to be 10.0.0.2, so I'm using that again. That's what it will pick up. And then, of course, overload means that we're going to use PAT address translation instead of network address translation. And so, of course, that means you can share lots more hosts can share that one address up to about 4,000. Now, I've put an alternate configuration here just because I can. And so basically, I'm not necessarily going to apply this. This just is an alternate example. And so it's IP. So instead of using this interface, we can, of course, use a NAT pool. And so this first line here defines a NAT pool called NAT pool 1. And we're using the addresses 5 through to 10. And it has a net mask of 24 bits. Again, we still need an access list. Oh, I didn't edit that, did I? Bad boy. I'm defining a different access list number, but it's exactly the same there anyway. So access list 2, again, the same address and wildcard mask. And so this command here, of course, is the PAT, port address translation. So as you saw when I edited it back to the other way, basically IPNAT inside source list. Now, of course, this is using list 2 instead of list 1. I could have reused it, but it doesn't really matter. And so instead of that interface command, we'll use, so this is basically saying, you know, what outside address inside global address am I going to use? So that's just sharing that one address. Here, we've got a pool of inside global addresses, which of course is that pool there. And of course, overload is the bit that actually changes it into being PAT instead of NAT. All right, so let's have a bit of a play. Got to admit, I didn't actually look into this very much. So let's just do a show run on here.
Oh.
Okay, so this is the configuration on the router as it is. So I've got some static routing and all kinds of stuff like that on there. So of course, these are the interfaces that have been configured. As you can see, there's no IPNAT insides or outsides or anything like that, and there's no IPNAT commands there at all. So basically, I should just be able to paste this whole big chunk in, and that should work a treat. Let's see if there's any errors. So IPNAT outside, IPNAT inside, IPNAT inside. ACL's there. That just went over the line. All right. So that's configured it. I don't see any errors. Maybe could do a show run again just to make sure it all stuck. So we have IPNAT inside, IPNAT outside. We've got IPNAT commands there. We've got the ACL. All right, great. All right, now let's, what's that one's address? 10102. Let's try and
Oh dear.
ping 10.1.0.2. Okay, that seems pretty good. Copy, let's do the same on this one. And let's have a look at the translations on the server. Let's see if that worked. Not on the server, on router 1. So, show IPNAT trans. Let's widen that up a bit. Okay, so basically we've got these dynamic translations that came up. And so as you can see, they're using 10.0.0.2 as the inside global. The inside local, of course, are the two host numbers that did it. And then we've also got these two static translations that I defined earlier. So we've got 10.0.0.3, which is translating to that server, and then we've got this port forwarding there as well. So that's all very nice. We can also do show IPNAT statistics. And so there's a total of 4 translations, 2 static, 2 dynamic, and 3 extended. Now, basically what might happen is these ICMP ones, because they're not TCP, it's a bit harder to keep track of the ports, and so they often time out. So they might have actually disappeared. It's just doing, yeah, they have. And so if we look at the statistics, though, there's 4 translations. 2 of them are static, which are, of course, these 2. And then there's still some dynamic left, and they're extended because they're that means that it's gone through PAT, basically, the port address translation. So that seems to be working all right. I suppose what we could do, something extra, is we could maybe do a web browse to that address. So we'll close that. Getting comments here, am I? 10.1.0.2. So hopefully we do have a web page. So let's have another look at the translations. And so you can see that connecting this one here is the dynamic one here. And so it's connected to the web port, of course. And so it's used 1025 as the internal port number. And so that all seems to be working pretty nicely. Now let's see if we can connect to the inside world. So we'll use the web browser on this one. Now I've got to try and remember the addresses. Now it was 10.0.0.3 for the static one. Okay, I'd forgotten I put that in. So of course, this is actually this server here. And so what I've done is I've just modified the page a little bit so that actually shows the inside local address. Of course, I typed in the inside global address to get to the server, but that works nicely. Now, because this is a translation for all ports, I should be able to ping that address as well. So 10.0.0.3. And I can actually ping that server as well through the NAT router. So we can maybe do a translation again, see what's going on. And so we've got some ICMPs coming in. And so it's showing the translation there. And we've also got the static as well as this connection here. And so that's basically, remember, the dashes just means that's the static one that's waiting. And of course, this one with all the fields filled in says that this is an active translation that's happening. All right, so that's one thing we've tried. Now we've got the other address to try, haven't we? So come along. There we go. So now we need 10.0.0.2. That should hopefully work to that other server. And yes, it has. So 192.168.4.20, of course, is the inside local address for that server, this one here. Of course, I've typed in the external there. Now, if I ping 10.0.0.2, it probably will work, but my guess would be that it would be the router replying. But I suppose we can give it a try. What we could do is we could trace route both, couldn't we? Trace route 10.0.0.3 first, which of course is to the first server. And so it's actually going through 3 different hops, all with the same address. Isn't that nice? But if I do it to 10.0.0.2, it's probably going to be shorter. Yes, so that was just the router that's replying to that. While this, of course, was all of the internal hosts were well, the 2 internal routers were replying. So it's R1 and R2 replying there, and that's the actual server itself replying. And so not particularly informative, but it does indicate by the number of hops that it's actually, that was the actual host replying, while this one, it's just the outside, the R1, the edge router. So that's pretty much NAT in a
nutshell.
Yes, a NAT shell. Okay. Hadn't thought of that, but I'll take your advice on it. So was that an understandable demo? And so I'll basically save these files up onto onto the file section on the Cisco server, so you can actually have a look. But yes, there is a text file there at the moment, but that's the older version where I hadn't actually put in this extra stuff about the NAT pool. I thought I'd do that just to be a little more thorough. So I might actually turn off the sharing just so I can see the WebEx interface again. So has anyone got any questions about NAT or any other topics that we've covered up until now? All very silent again. Yeah, so next week, basically it's just device discovery and monitoring from memory is the topic. And so there's not a big amount of configuration for that, but I certainly will demo it. But next week, the demo probably will be a bit longer. Because I'll also demo a trial practical test as well. Okay, so someone's typed in, I would like to know where I can find your practical classes recorded. Well, basically, on the files, where is my Cisco page? So basically, I'll go back to the root directory. Basically, there are links in this document here to everything that we've done, both for CCNA1 and CCNA2. So this is a Word document with all the links. Now, basically, when it comes to the demos, some of them are basically directly from the WebEx recordings. But last week, for Chapter 8, I actually I used that download link myself, and I converted the file into an MP4 so I could then upload it to YouTube. And so that's where it is. So basically, all these links here have it. I've also been giving these links to, oh shit, I'm not sharing, am I? Just a sec. Where are we? So sorry, I'll just back. So of course, under Files, Cisco 2, there's this CCENT video links file. So that's where I've got all the links that I've created for all the videos I've done. And so when it comes to demos, I started off just using the recordings from WebEx, but basically, if you download it, you've actually got to download other software to be able to watch it, and it's a bit of a strange video format. So last week, I actually changed the file. I mean, changed it a little bit. I downloaded the demo myself from WebEx, and then I converted it into an MP4 and then posted it on YouTube. So that's last week's. So basically, the other ones, the download and the play ones, just done a little bit of different formatting for each one, sadly, are basically in that file as well. Now, I have given these links also to Anna, and she's telling me she's been putting it on Flow, and so they should be available there as well. But yeah, it's just the video CCENT video links file in Files is where I've put all the links for you that I've done up until now. Covers it. Yeah. Close. And so that's where I put that. So yeah, next week I'll have a practical test for you to have a play with. I'll also activate the practice final theory test, because in 2 weeks' time will be our testing day, basically. So that's when the exams start, isn't it? So yeah, so next week, as I said, will be just a quick demo on discovering devices and monitoring, and then I'll also do a bit of a demo on the practical test, on something similar to the practical test. Does anyone have any other question? Did I answer your question? What are the chapters that would mainly focus on the final exam, hands-on skills? Well, basically, I'm going to say the more important ones would probably be, routing. What else? Yeah, the switch configuration. They're probably the more important ones. So, with the port security and all that on switches, VLANs, and basically, those topics. While other, so basically, they're the most important ones, certainly. So ACLs, DHCP, and NAT. You may well have some DHCP to do, but I don't remember there being a lot on that. It might have been merit from memory, but that's the basic behind it all.